Example 2. A particle moves in a straight line with position relative to the origin given by this function t cubed subtract 3t plus 1. We're dealing in displacement of centimeters and where time is in seconds. Now time has to be greater than or equal to 0, and that's going to be important. Part A, find expressions for the particle's velocity and acceleration and draw sign diagrams for each of them. So this is the displacement function. Velocity function is its derivative. So part A, velocity function is the derivative of the displacement, which equals 3t squared subtract 3. Let's draw a sign diagram of that. We need to find its critical values. So finding its critical values means setting this to be equal to 0. So 3t squared equals 3, t squared equals 1, so t is plus or minus 1 when we take the square root of that, but time cannot be less than 0, so it has to be plus 1. Okay, so we have on our sign diagram this point 1. We could put the negative 1 as well for a moment just to see what the sign diagram looks like. It's a quadratic. It opens up, so positive, negative, positive. Okay, but t has to be greater than 0, so the real sign diagram just looks like this, where this is 0, this is 1, and it's only this portion, so negative plus. Okay, so we're not counting this one. This is our sign diagram here. Acceleration function is the second derivative of the displacement, or the derivative of the velocity, so 6t. And the sign diagram there, the only critical point is 0, because 6t equals 0 when t equals 0. Okay, but t can only be greater than or equal to 0, so really the sign diagram looks like this. T can only be positive, which means that 6t will also only be positive, so there's our sign diagram for A of t. And this one is for V of t. Part B, find the initial conditions and hence describe the motion at that instant. So initial conditions means when t equals 0. So initial conditions, we're looking for S of 0, V of 0, and A of 0. We just fill in the number 0 for each of these functions. Filling in 0 for our S of t will give us 1. Filling in 0 for V of t will give us negative 3. And filling in 0 for A of t will give us 0. This displacement is in centimeters. Velocity, centimeters per second. Acceleration, centimeters per second squared. Okay, so, and describe the motion at this instance. So the motion at that instance, the object is 1 centimeter to the right of the origin. The velocity is negative 3 centimeters per second. And the acceleration is 0 centimeters per second squared, which means at that moment there is no change in velocity. C, describe the motion of the particle at t equals 2 seconds. Okay, so C, we need to calculate S of 2, V of 2, and A of 2. When we do that, I won't go through all the algebra, but when we do that, we end up with 3 centimeters, 9 centimeters per second for velocity, and 12 centimeters per second squared for acceleration. Describing this, we've got the object is 3 centimeters to the right of the origin. It's traveling at a velocity of 9 centimeters per second, acceleration of 12 centimeters per second squared. And notice that the V and A have the same sign. So what does this mean about the speed? Therefore, the speed is increasing. Okay, so velocity, it's moving in a positive direction. Acceleration in a positive direction. Therefore, the speed is increasing. Part D, find the position of the particle when changes in direction occur. Changes in direction occur when v of t equals 0. So what's going to cause that to happen? Well, we've already figured that out right here, when t equals 1. Find the position of the particle when it changes direction. Okay, so the position is s of t, so in other words, we need to calculate s of 1. And s of 1 is -1 centimeters. That means 1 centimeter to the left of the origin. Part E, draw a motion diagram for the particle. Okay, so this is just on a horizontal axis. Here's our origin at 0, 1, 2, 3, -1, -2. So we're talking about at time as 0. Take a look and see where the object is. We're talking about displacement here. So the object is at 1 centimeter. It's here. Okay. If the object travels all the way back, it's going in a negative direction at that time. Velocity -3 centimeters per second. So it's traveling to the left. It changes direction when it's at this position. Okay, so we know it's traveling to the left, and then it's changing its position and coming back again. And it just continues on like this. Part F. For what time interval is the particle's speed increasing? So particle speed increasing. Now, remember, speed increasing means that v of t and a of t need to have the same sign. Need to both be positive or both be negative. Okay, well, signs. Analyzing signs is easy with a sign diagram. So if we take a look at those two sign diagrams that we already drew, but we can put them right next over top of each other even. So let's take a look at v of t. It is this one here, 0, 1, negative, positive. Take a look at a of t, 0, and the whole thing is positive. Okay, where are those two signs the same as each other? In this portion, when t is equal to or greater than 1. And that's 1 second. And part G. What is the total distance traveled? Total distance traveled in the time from t equals 0 to t equals 2. So t equals 0 to t equals 2. We can actually analyze this based on part E from our motion diagram. T is 0. We were here at 1. And t of 2, we calculated that somewhere. When time is 2, where's the displacement? Here it is. When time is 2, the displacement's at 3, which is here. But first it needed to come back this way and then go this way. So that's 2 units, and 2 more units is 4. 2 more units is 6. So the answer to G is 6 centimeters is the distance, total distance traveled.